the software in a quantum computer is built on the principles of quantum mechanics. So rather than conventional computer, the principles are the principles of logic, so the AND gates and the OR gates, things like that. The principles of quantum computing are similar in concept, but actually built on the principles of quantum mechanics. And so they involve, there's this business of superposition of particles. So you have these things called qubits, which sound similar to a regular bit, but they're not, in the sense that they behave according to quantum mechanics. So a qubit, when you measure it, will turn out to be a 0 or a 1, but up until that point, it's this superposed thing which is both a 0 and a 1 in some sort of probability distribution. And the QLM actually takes that into account. So what that means, what this superposition means, is that with two qubits, you have 0, 0, 0, 1, 1, 0, 1, 1, all built into those two qubits. So you have like an exponential increase in the amount of information that you can get into any number of qubits. And what that means is that when you go up in terms of numbers of qubits, you very rapidly get to a point where the number of qubits on a quantum computer has more information content in it than the biggest supercomputers. And if you could build a perfect quantum computer, we can't do that yet, but if you could, then you'd need only 50 qubits or so to get to an information content in that quantum computer that's bigger than the biggest supercomputer that you can build.